Hi, and welcome to this installment of By Manufacturers Direct, Execs and Techs, where we sit down with industry experts and innovators to discuss trending topics concentrated in the surface preparation industry. In this ongoing series, we'll examine traditional methods and best practices, as well as review our industry's most popular pieces of equipment, while taking a peek behind the curtain of the engineers and manufacturers who build them. We'll also explore and experiment with commonly used products in addition to introducing new cutting-edge technology. Joining me each episode is our resident subject matter expert, former contractor, and current Substrate Technology President, Josh Jones. Each episode, Josh and I will discuss various aspects of our industry. We'll explore topics from both rudimentary and experienced perspectives in an effort to advance the knowledge of both beginners and seasoned veterans. Throughout this series, we'll ask our audience to help identify and nominate future discussion topics by subscribing to one of our online platforms and submitting your suggestions in the provided comment section. Hello, and once again, thank you for joining us for our continued educational journey through surface preparation. My name is Kevin Hawthorne, and I'll be joined by industry patriarch and corporate president of Substrate Technologies and Impacts Americas, Josh Jones. Today, we launch our third video in a 10-part series highlighting fundamentals of surface preparation. In this episode, we're going to dive into the details and the critical elements of shot blasting, or sometimes referred to as bead blasting. As always, we hope you find this discussion not only informative, but beneficial to your business. Okay, Josh, once again, welcome to the show. It's great to have you here and your expertise. Today, I want to focus on one mechanical process specifically, and that's shot blasting. We've touched on it a little bit in previous episodes, but we get a lot of questions on what exactly is shot blasting, the benefits of it, the range of machines, the range of shot. There seems to be a lot of questions that are surrounding how do I become an efficient contractor with a shot blaster, and when should I use shot blasting versus other mechanical processes such as grinding or scarifying. But to begin with, for somebody from an observer like myself who doesn't have a lot of experience, kind of tell me what is a shot blaster and how it operates.
Well, in the simplest sense, it's like a sandblaster. A shot blaster is accelerating a media at the surface. In the case of a shot blaster, it's going to be steel media. The media is accelerated at the surface with the intent that when it hits, it's going to break away small pieces of the concrete or the substrate, whether it's steel or concrete. The material that's removed is then rebounded and taken back to the dust collector so that the surface is completely clean because it's all done in a closed circuit. So it's very similar to sandblasting, which normally equates to a lot of dust as the material is accelerated at the surface, and as waste is made, it flies everywhere. Inside a shot blaster, the intent is that it breaks away the pieces, removes whatever's on the surface of the concrete, and then removes it right to the dust collector. So it leaves a nice profile, whatever the manufacturer might specify, and also it's immaculately clean. With regard to your question about when I would choose to use a shot blaster, my personal opinion is if I'm putting down a system, a coating system of some kind, I would always go back to the manufacturer to have them tell me what I must do for their coating. Because ultimately, the ability of the material to perform, to be able to bond to the concrete, and also for the sake of its longevity, it's going to be very dependent upon the preparation of the substrate that it's being applied to. So if a manufacturer specifies shot blasting, then there's no alternative, in my opinion, to do right by the material, because I am in service of the bond of that material when it hits the concrete, so that it fuses to it. If shot blasting is specified, there's no opinion on the matter. I would do the shot blasting as a material mandates.
So we should always look at the specifications from the material we're going to apply to kind of dictate the profile that we need to create. And that will dictate what size shot blaster we're going to use, size shot, or the mechanical process itself.
That's a good question. With regard to the material and its performance expectations based on the thickness of the material. And the reason I say it that way is because when a floor is trafficked or used, if it's specified for a certain amount of traffic, then the thickness is going to be already specified by the manufacturer, the architect, the engineer, whoever it is that requires a certain type of coating for the environment. They're going to specify the mill thickness, how thick that coating is. If a shot blast is what's required for the coating to bond to the concrete, it could pretty much be expected that the thickness that's specified will be enough that it will absorb, some will absorb into the concrete and some will also attach to that profile and submerge or bury the profile. So the coating, if needed, is going to have, let's say, an orange peel or even a glass-like look. That profile that's underneath there cannot telegraph through that coating. If, however, let's say the profile is requires 20 mils of coating to prevent the telegraphing of that profile, and only 10 mils of coating is applied, well, we can expect that the profile from the shot blasting is going to telegraph through the coating. That's usually not going to be something that a facility owner would want in their floor, is to see the preparation method that ensured the coating stuck to the concrete, because you'd be seeing all the marks beneath it. So it's really a matter of understanding the product, the specification for its thickness, the profile type that it needs for, let's say, the shot blasting, because everything works together. Ultimately, the floor system is going to traffic and be viewed from above. So everything that happens below it already has to be planned ahead of time, what that system needs to bond to, as well as conceal, so that you get an attractive, aesthetically appealing, and also from a performance standpoint, proper coating system.
So if I'm understanding you correctly, one process does not fit all. I think it would be important, especially on the larger square footage projects, that as you're buying your material, yield is very important. So if you're overblasting, which is a term that I've heard, and you're putting down a thin mill system, not only aesthetically could it look bad, but you're not going to get a very good bond because you don't have enough material. And vice versa, if you have a very hard, aggressive blast or profile, you need a lot of material to fill up those voids in the peaks and valleys. So to your point about matching them, I would think from a contractor's perspective, it's very important to match material thickness with your mechanical process to make sure that there is some cohesion there.
Yeah, absolutely. Again, when it comes to systems for floors, if a contractor is not qualified to specify a full system, meaning from the surface preparation, well, let's say that structurally, the structural slab, let's say, and it's state that it has to be in order for the coating to stick. Usually the manufacturer will mandate that. But if I'm going to specify my own system, then I have to be qualified to do so, meaning I'm going to take into account the slab, the profile, the material I'm using, and the final finish that the owner wants. The nice part is most systems as a contractor are going to be handed to me. The specification is going to be handed to the contractor that says, we need this particular floor system installed. Now, the contractor is responsible to clarify with the supplier or the manufacturer of the products how everything is supposed to be done to ensure that the coating comes out the way the client wants. Again, because from the aesthetic standpoint and from the performance standpoint, we only know that once it's finished. But again, all these other things have to take place in advance of that. So, you mentioned overblasting as an example. Overblasting is not something that's going to be specified. It's a mistake in surface preparation. So if a floor is damaged to a certain point where the coating has to, let's say, the volume be increased to try to bury the mistake, and that happens. It does happen on large blasting jobs. It probably happens quite often. And that's something that the contractor has to plan for, because it's done by human beings. So there are going to be certain mistakes made and can be repaired. But when it comes to the profiling of the concrete, within a certain margin of error, there's an expectation that concrete will have a certain profile that the system has been specified to absorb into, bond, and also, for lack of a better term, bury, so that the profile of the floor below it doesn't telegraph through. But overblasting is not a bad term. It just simply means that the shot blaster was more aggressive on the concrete than was intended. And so now I have more aggressive profile that I have to mask or bury underneath that material.
Okay. Let's talk a little bit about the specific mechanics of a shot blaster and how it operates. I know you're loading the steel shot that you mentioned earlier. So you're loading that into a hopper, and then what happens? How does the shot actually physically alter the condition of the floor?
Well, inside the blast housing, which is where the shot blast wheel is contained, that's where the shot falls into, and that wheel spinning at 6,600 RPMs, the shot falls out of the hopper that's just above it by gravity. When it hits that rotating wheel, the wheel will accelerate the shot. So that is how the shot gets moving. So as the shot is thrown to the floor at a certain speed or velocity, the pieces of steel that make up the mass of the abrasive, the shot itself, they're literally hitting the surface of the concrete and breaking a small piece of it away. And when I say small, an S330 piece of shot is quite tiny, and when it hits the floor, the piece of sand that it takes with it is equal to or a little bit bigger than that piece of shot, depending on the hardness of the concrete. So they're very small pieces of metal. They're not very large, but the idea is that I don't even know the quantity, millions of times over, those shot pieces are hitting the concrete and eroding it like sandblasting or like power washing, where it just breaks away small pieces that eventually add up to large amounts of volume. Once that takes place and those pieces are broken free, the machine is run under negative pressure thanks to a dust collector. So as the shot hits, the dust is created. The shot and the dust both bounce off the ground, partially because of rebound or ricochet. As it bounces up, the negative pressure from the dust collector then takes over from there in the circuit, lifts the shot and the dust to the top of the circuit. The dust, being lighter, gets cycled out to the vacuum or the dust collector. The shot, if it's still usable, because it can be used over and over until itself is depleted to the point of dust, the shot will then go back into the rotation and then the circuit starts again. That is definitely a snapshot of what's happening at any given time that a shot blaster is being run. But that's how it works. Basically, it's almost like a circle. If you look at it from the side, shot drops down to the ground, makes dust, dust and shot come up, cycles out or filters out the dust from the shot, and then the shot goes back in and it happens again. And that just continuously goes on.
So the shot would continue to go around and rebound and round and round until it becomes so small that it's affected by the dust collector and gets sucked out because it's no longer providing any advantage in the process.
Yeah, I mean, its mass has been reduced to the point where it's dust itself. It's ineffective to do any kind of work on the floor. And again, the physics is already worked out by the engineer of the shot blaster. But basically, the air movement, the velocity of the air moving through the circuit, it's going to carry that piece of steel shot that now has such a low mass that the circuit doesn't really distinguish between it and dust by weight. It just becomes dust itself. So on a shot blaster that's working properly, you're only ever just adding shot to it. You're never taking, let's say, shot out. That takes care of itself.
So the shot is a consumable that is used until it's gone. Are there any wearable parts in a shot blaster that a contractor should be aware of, should keep an eye out for? What are the general wear parts and maintenance that someone should look out for that's operating a shot blaster? Or if they're renting one, what are some things they should look out for even before they start operating?
Well, yes, there definitely are consumable items on a shot blaster, because what's happening is the steel shot itself is not abrasive on a machine, but the dust that it makes, the concrete dust, very much so is abrasive. And as that circuit is being run and the shot is thrown at the ground and makes dust, you now have dusty shot. Well, that shot moving through the system is going to wear away at anything that it comes in contact with, which is why the inside of a shot blaster will have a lining system that is made of manganese and actually is along the inside of the housing itself, because that's where it's known by the engineers of the machine that the dusty shot is going to pass and would otherwise literally eat a hole through the side of the housing. And then also the shot blast wheel itself is made of the same material. Again, the same reason, because that shot, when it falls into that wheel spinning at 6,600 RPMs, the shot doesn't hurt the wheel, but the dust that's encapsulating the shot, very small amount, but just enough. And again, a million times over, that metal is being abraded by that dust continuously. So it is also a consumable item. Like the shot, eventually it will get worn away from a different mechanical abrasion standpoint than, let's say, the shot breaking down from hitting concrete. Nonetheless, it's still abrasion by the concrete itself, because that's the waste it's making. So yeah, blast wheel and the liners that protect the housing. If a blast wheel is not replaced, it will eventually break. It will eventually shatter. At that point, there's no choice. It has to be replaced because the machine it cannot be run at that point. Liners can be ignored, but liners are there to protect the housing. So if the liners are not changed on a regular basis, what they're protecting, as they start to wear away, literally the shot and the dust will eat a hole through the side of the machine, and that part of the machine would have to be replaced.
So the $64,000 question is, how long do wheels and liners last? Is that something that should be replaced between every job? Is it something someone needs to monitor on a certain amount of hours? As a contractor, what's the matrix for identifying when you need to change those parts?
The blast wheel, I always tell people I would check it every 20 hours. If a shot blast wheel is showing wear at 20 hours, then there's a good chance that the concrete that's being blasted has been abrasive, because that's a pretty fast wear on a blast wheel. But it's always best to know ahead of time the condition of a wearable part before the process starts, because the most expensive time to fix something is when it breaks unexpectedly on a job. So the idea is at the start of the shift, if it happens to be on 20 hours or just as a regular daily habit, to check the wheel with a flashlight and literally just inspect the fins of the wheel itself to make sure that it's okay. I would start doing that at 20 hours. If it looks perfectly brand new after 20, I would check it in the next 20. With regard to the liners, that's a little more difficult of a process to check to check those liners. But the general rule of thumb is to check the liners at about the third or fourth wheel change, because the liners will wear much slower than the wheel, but always in relation to the wear of the wheel, because the work they do or the way that they're being abraded versus the way the wheel is being abraded, it's about a 5-to-1 ratio. So for every 5 wheels, I'm changing the liners 1 time. So if I change a wheel at 20 hours, that means the liners are changed at 100 hours.
All parts created equal. What should somebody look for? Looking on the internet, you can find dozens of suppliers of wheel kits and liners. Is it like any commodity where there's some that are better quality than others? Are there things contractors should look for when they're buying these consumables? How does one protect themselves by buying junk?
Well, I would always defer to the manufacturer of the machine. I would ask what they recommend. Now, granted, they are the ones that are going to be selling the parts of the machine they make. But when it comes to the expense of these machines, and more importantly, what it costs for downtime, because of, let's say, parts that are defective or parts that are of a lower quality, the labor cost to operate that machine, and more importantly, to maintain that machine, is going to go up, because the less time I get out of an inferior part, let's say, the more labor I have to spend to maintain that machine. My advice would be to always check with the manufacturer of the machine and what they recommend. If I am going to go to the internet and buy something from some other supplier, buyer beware. There's no way to know. There's no way to verify the quality of those products.
Okay, let's move into the machines now. There are machines that are as small as hand shot blast machines up to machines that I've seen that are used for road work. Are there major differences between those machines? Are there different applications that you'd use for those machines? If I'm a contractor, can I buy one machine that'll do everything? Or am I forced to buy 3 different machines, 3 different sizes to do different types of work?
With regard to the shop blasters?
Yes.
The shop blaster size that's being purchased, that's going to be for whatever application there is, in my opinion, is always going to be dictated by the production that's required. The bigger the machine is, the faster we'll go. With regard to your question about a handheld machine, that would definitely be for areas that are too small to get even the smallest walk behind blaster into, or vertical applications where a shop blast is absolutely required. And of course, a floor machine cannot be used vertically. So a handheld would make sense there, except the handheld is very slow because it's very small. But the way it works and the profile that it leaves on the floor, if it's run correctly, is going to be the same as any of the machines. It's just how fast it gets it done. Because again, it's just physics. It's how much material, how much shot can be thrown at the substrate in a given time to produce that profile. The bigger they are, the faster they go. But when it comes to, let's say, what a small blaster can do versus a big one, maybe a small blaster would struggle on a certain kind of a paint or a floor enamel or even adhesives. Some people are able to take adhesives off with their shop blasters. Well, if I need to take adhesive off a floor and I use a small machine, it's going to take me that much longer because I don't have as much ability to throw that amount of shot at the floor to eat through, let's say, adhesive, which normally doesn't blast very well. If I have a big one, though, then I certainly could take the adhesive off the floor with that bigger machine. But what has to be remembered is the amount of damage that has to be done in order to remove that adhesive, because I have to chew with that bigger machine through that adhesive, break enough of the concrete away to take it with it, to come with the adhesive. And then therefore, I've now changed the elevation of the concrete. I've more than likely left the floor more rough than maybe the coating requires. So in that case, maybe the blaster is not appropriate. The only way you can really say that, one machine makes more sense than another over, let's say, what the machines are made to do. Brand new hard trowel concrete with cure and seal on it. All we need to do is just open it up. Then it's just a matter of how fast I need to go. All the machines will profile the floor exactly the same way. It's just a matter of how fast it gets done.
Well, actually, you bring up a good point. We didn't touch on earlier the different types of substrate that shot blasters are used on. I think primarily for our conversations, we're talking about concrete, but are there other surfaces where shot blasting would be appropriate?
Steel and asphalt. It's not something that I've specialized in, but steel and asphalt, especially abroad, shot blasting used quite often to clean those surfaces. Bridge builders, existing bridge decks where anti-corrosion has to be applied. Steel, of course, on ships. But steel, asphalt, and concrete are probably the three major surfaces that would benefit from a shot blast if the following treatment or the treatment that's going to be done requires it.
Good. What else do we know about shot blasting? What other type of niches should we know?
Well, I think the most important thing with a shot blaster that I find to be the most unique about the machine is the fact that it will leave the floor completely dust-free. No other procedure, no other surface procedure for concrete will do its work and leave the floor as dust-free as a shot blaster. And it's only because when the media is accelerated at the floor and it's done under negative pressure, as soon as it creates that waste, it has nowhere to go but from that area. So that means that floor is immaculately clean. Now, by making it immaculately clean, and especially in preparation for a coating, when a coating hits the surface of the concrete, it has nowhere to go but in. And that's in the formulation of the product. But as long as we can get the coating to absorb into the floor and it cross-links and hardens, that concrete has become harder than it was before the process was done, because it's been infused with the material, because anything that would slow it down from absorbing in is gone. There's also no chance for any kind of chemical reaction or reaction with whatever dust may have not been removed by other methods, because it's just pure concrete. So the resin can soak right into the concrete and literally become one with the surface, to the point of failure that the concrete literally pulls apart. The coating doesn't delaminate.
So if I'm a contractor and I can only purchase one shot blaster, am I restricted to the type of work I can do? For example, if I buy a larger machine, should I stay away from garage floors? If I buy a smaller machine, should I stay away from large square footage projects? Am I restricted by the machine that I buy?
Yeah, probably. It depends on how many square feet have to be done in a given time. Because again, the bigger they are, of course, the less mobile they are. You know, to get into a small space, let's say it's going to be difficult to get a 1,000-pound blaster into a small space downstairs. So in that case, the so-called cheap small machine would get the job done quicker because it can get into that space. But when it comes to the work that can be done, when people ask what blaster they should buy, I always ask, well, how many square feet do you need to coat in a day? Because if the blaster can do 1,000 foot an hour, as an example, but the most you can coat is 2,000 feet based on work crew in a day, you don't need 1,000 foot an hour machine. Maybe you do, but my point is that I really only care about what I can prep in a given amount of time that can actually be coated within a day or two to prevent any future contamination that might take place. I'd rather blast and coat. If I want to try to stay ahead with the shot blasting, like on a parking deck or a big open warehouse, then certainly, you know, a machine that does 10,000 feet an hour makes sense. But it just depends on how many feet I need to do per day, let's say, and also how difficult the access is going to be into the space.
Let's talk a little bit about the power requirements for machines. I know that the larger machines require more power. I would also imagine at that point you need to buy some special generators, or you got to be able to get that power to the machine. Obviously, you're not going to take a 480 machine into a residential environment. So talk a little bit about, from the smaller machines to larger machines, the power that's required, and what are the environments that you typically see those type of machines in?
Well, if we start with the smallest machine, that would be small commercial, residential, you know, where the power that's readily available is probably going to be 110 volt. In that case, you know, a small machine, 110 volt machine, horse and a half, it's good for about 400 feet an hour. It's going to be good for the smaller jobs because it's very convenient. I can usually just plug it into the wall or a small generator and it will do its work. Of course, its production is less than a bigger machine, but for the smaller space, that might be appropriate. If we move into a larger machine where the power requirement is going to be greater because the motor size is bigger, then of course we would have to either find that power in a panel in the space, or we'd have to have a generator for it. If we move into the ones that are made for a parking deck, as an example, where it's probably going to be difficult to find power on site, not because the power is that unique. It's just on a parking deck, there's not usually readily accessible power in a panel because it's not usually a space that uses that much power. So now we're probably getting into a tow behind generator maybe to run that larger machine. But you know, my opinion is the square footage that's needed to be done in a given day, and it's a good conversation to have, but the place to start is how fast do I need to get the work done? After that, then of course we have to talk about power requirements, access, how we're going to get into the space, how it's going to be transported. You know, if it's a customer that I'm working with that wants to know about using a certain machine, even if it's being rented, how are they going to get it into that space or from the rental place to the job site? Because the bigger it gets, the heavier it gets. So logistics also play into that as well, which is why it's very difficult to just make a question tree or a decision based on the specs of the machine without talking to somebody who's familiar with the equipment.
Yeah, obviously there'd be a lot of ancillary type of decisions that I think would go into a purchase of a large machine. Like you said, mobilization, power requirements. Are you looking at buying a generator, renting a generator? Are you looking at working jobs where power source is typically available? And I think those are all things to kind of remember, not just with shop blasters, but with a lot of mechanical equipment, that larger machines require different type of mobilization and power, that those things need to be taken into consideration prior to a purchase. So without getting into specific brands, can you talk about advantages of designs of certain machines over others that might be more beneficial to a contractor?
When it comes to the different designs, I would say that the thing that's probably going to be seen between the different brands would be forward walking and backward walking. I know that's usually a topic a lot of people like to discuss with regard to why some machines walk forward and some walk backward. But the way it's been explained to me, and I agree with it, is that for the smaller machines, they're made for the smaller spaces. So they need to be a little more agile to get around obstacles. They need to be easy to turn and steer. The problem with a small one, besides the fact that they're not as productive as a big one, is that it's very difficult to keep a small machine that walks forward straight. It's difficult to keep a straight line, where walking backwards, it's going to be easier to keep a straight line. So for that reason, the bigger ones are walking backwards. For them, it's forward, but for the operator, they are walking backwards. And the best way to say that one makes sense over the other is try to push a suitcase on wheels versus drag a suitcase on wheels in a straight line. And that's probably the best explanation of why one way makes sense over another. But when it comes to different manufacturers of the machines, they all work pretty much the same way. As far as, you know, forward or backward, that's probably the only difference. Maybe power as well, but the process is again very straightforward. It's been around since the 80s of accelerating a media at the floor, making the dust under negative pressure, removing it from the space, and leaving a profile behind.
If I'm a contractor looking to get into startup garage floors, and I'm looking at the various brands of shop blasters out there, you'd mentioned earlier that, you know, an 8-inch 110 machine probably does about 400 square feet an hour. Is that the norm? Would some give me more square footage than others? Would there be, I guess, are there engineering advantages of one machine over another, or the type of machine over another, without brands, but the design of a machine?
Well, I think the most important thing to look at with regard to shop blasting is the efficiency of the process. As long as we keep in mind that the production of the machine is based completely on the amount of shot that can be delivered to the surface, because that is the working end of the machine, at least from the floor standpoint. Whichever machine will support the most amount of shot being delivered to the surface, which means it will erode that much more concrete, then that's the machine that's going to go faster. So if one model uses a power input of 1.5 horses and it puts out 400 feet an hour, and another model uses the same amount of power, but let's say only gets 200 feet an hour, well, it's the same power. So the only thing that's affecting its speed can be the amount of shot that's being delivered to the floor. The speed is the same as far as the shot delivery, but the only way it can be going faster is because it's able to deliver more. If that's the case, then again, it really does come down to brand, specific brands, because the amount of shot that's being delivered to the floor, anything that's put down has to be recovered. So if one's not able to put as much to the floor, it's probably because it's not being recovered or moved out of the way of the new shot as fast. Some brands just do it better. With regard to the power input, though, it's the same. The shot is the same. It's really a matter of the efficiency of that circuit and how fast shot can be delivered and moved right through that circuit to keep making a profile.
Great. Well, this has been a great discussion. I've learned a lot about shot blasting, and I appreciate you taking the time to explain it to us. And we'll look forward to continuing the conversation on a different topic next time.
Sounds good. Thanks very much for the opportunity. I appreciate it.
Thank you, Josh. Take care.
Thank you for sharing your time with us. If you enjoyed today's educational installment and would like to be notified when we release new segments, click the subscribe button below. If you'd like to suggest a topic for a future episode or have questions pertaining to this week's subject matter, please feel free to leave us a comment. And as always, we invite you to visit us at buymanufacturersdirect.com to view tutorials or purchase some of our industry's most respected and recognizable brands.